The breathtaking Io images and Jupiter discoveries from NASA's Juno Mission. Update 2025. For centuries, Jupiter, the largest planet in our solar system, has captivated scientists and stargazers alike. Its swirling clouds, powerful storms, and mysterious moons make it a fascinating subject of study. To unravel these mysteries, NASA launched the Juno spacecraft in 2011, a mission designed to probe the secrets of Jupiter. Let's take a closer look at Juno's journey, its remarkable discoveries, and the breathtaking images it has captured. Juno was launched on August 5, 2011 aboard an Atlas V rocket from Cape Canaveral, Florida. It embarked on a 5-year journey covering a staggering 2.8 billion kilometers or 1.74 billion miles to reach Jupiter. Along the way, it performed a gravity assist maneuver near Earth in 2013 to gain speed for the long journey. This slingshot technique highlighted NASA's precise planning and ability to use gravitational forces to reduce fuel consumption. On July 4, 2016, Juno entered Jupiter's orbit, marking the beginning of a mission that would revolutionize our understanding of the planet. Its orbit was carefully planned to minimize exposure to Jupiter's intense radiation belts, allowing it to collect data while staying operational. Juno was designed to be a highly efficient and durable spacecraft, capable of withstanding Jupiter's intense radiation and harsh environment. It's powered by 3 large solar panels, making it one of the most distant solar-powered spacecraft in history. Unlike other probes that use nuclear energy for deep space missions, Juno's reliance on solar power marks a significant engineering achievement. Its onboard instruments include high-tech tools like the Juno Cam, microwave radiometer, magnetometer, and ultraviolet spectrometer, which allow scientists to study Jupiter's atmosphere, magnetic field, and interior structure. Its mission, originally planned for 35 orbits, has been extended to 77 orbits by 2025, and it continues to provide groundbreaking discoveries. Over the past 2 years, the spacecraft has sent back amazing images, fascinating data, and new insights that help scientists better understand Jupiter and its dynamic system. Juno's journey to Jupiter has been a marvel of engineering and science. It traveled nearly 3 billion kilometers to reach the gas giant and relies on solar power to operate, an impressive feat given the faint sunlight so far from Earth. Once it entered Jupiter's orbit, it began capturing some of the most detailed images ever seen of the planet's swirling storms and polar regions. One of Juno's most popular features is the Juno Cam, a visible light camera designed to capture breathtaking images of Jupiter and its moons. Although Juno Cam's primary purpose was educational outreach, it has exceeded expectations by providing stunning views of the planet's swirling storms, polar regions, and cloud patterns. Juno Cam has photographed Jupiter's Great Red Spot, a gigantic storm larger than Earth that has been raging for centuries. The images revealed unprecedented details of its structure, showing intricate swirls of orange, white, and red. The spacecraft has also captured mesmerizing shots of Jupiter's poles, displaying dazzling auroras caused by interactions between the planet's magnetic field and solar wind. These images aren't just beautiful, they help scientists study Jupiter's weather systems and the processes driving its storms. Juno has made groundbreaking discoveries about Jupiter's atmosphere, overturning many assumptions. For instance, Jupiter's polar cyclones and enormous storms clustered at the planet's poles. These cyclones form unique geometric patterns, with smaller storms tightly packed around larger ones. Surprisingly, these storm systems don't merge or drift apart, leaving scientists wondering about the forces keeping them stable. It has also provided valuable information about the planet's deep atmosphere, revealing that its famous striped clouds extend much farther than previously thought. Winds in these bands reach incredible speeds, up to 620 kilometers per hour, and penetrate deep into the planet, offering clues about how Jupiter's weather works. Another significant finding was the uneven distribution of ammonia in Jupiter's atmosphere. This discovery suggests that the planet's weather systems are more complex than expected, with large-scale circulation patterns that may resemble conveyor belts transporting gases around the planet. The spacecraft also provided insights into Jupiter's iconic Great Red Spot. Scientists found that this massive storm extends deep below the visible cloud layers, suggesting that the dynamics driving it occur within Jupiter's interior. One of Juno's primary objectives was to study Jupiter's magnetic and gravitational fields, and its findings have been nothing short of extraordinary. The spacecraft discovered that Jupiter's magnetic field is much more irregular than Earth's, with regions of unexpected intensity and polarity. This suggests that the processes generating the magnetic field occur closer to the surface than previously thought. Juno also mapped Jupiter's gravity, uncovering asymmetries that provide clues about the planet's internal structure. These measurements have revealed that Jupiter's core is not as solid as once believed. Instead, the core appears to be a diffuse mix of heavier elements surrounded by hydrogen and helium. This insight is reshaping ideas about how gas giants like Jupiter evolve over time. Another interesting discovery was made possible by Juno's unique orbit, which allowed it to fly over Jupiter's poles, a region that had never been explored before. The spacecraft captured stunning images of polar cyclones and massive storms arranged in geometric patterns at both poles. These cyclones are tightly packed yet remain stable over time, presenting a mystery about the forces that keep them from merging. Additionally, Juno's ultraviolet spectrometer observed dazzling auroras at Jupiter's poles. Unlike Earth's auroras, which are primarily caused by solar wind, Jupiter's auroras are driven by the planet's rapid rotation and interactions with its moons, particularly Io, the most volcanic body in the solar system. Juno hasn't just focused on Jupiter itself. It has also turned its attention to the planet's moons, especially Io, Europa, and Ganymede. Io, known for its extreme volcanic activity, was observed emitting a stream of charged particles that interact with Jupiter's magnetic field, creating powerful auroras. Using its infrared instruments, it was able to map Io's surface, capturing detailed views of its fiery volcanic activity. It identified lava lakes and hotspots, particularly in Io's northern latitudes, showcasing the immense power of tidal forces caused by Jupiter's gravity. This intense gravitational pull generates heat inside Io, driving its constant volcanic eruptions. These discoveries are helping scientists understand how similar forces might shape other planets and moons across the galaxy. Jupiter's other moons haven't been left out of the spotlight. Juno has gathered data on Europa, a moon believed to hide an ocean beneath its icy surface. Its observations of Europa revealed evidence of water vapor plumes erupting from its icy surface. These findings have strengthened the case for Europa as a potential site for extraterrestrial life. Juno's also observed Ganymede, the largest moon in the solar system, and its magnetic field, providing new information about its icy crust and internal composition. Another one of Juno's key goals has been to measure the amount of water in Jupiter's atmosphere, which has turned out to be more complicated than expected. Scientists initially thought water would be evenly distributed, but Juno's data shows it varies across the planet. This finding challenges existing theories about how Jupiter formed and suggests water played a crucial role in the early days of the solar system. Learning more about Jupiter's water content could even provide clues about how life began on Earth, or if life on Earth originated from another planet, like Jupiter, through meteorites, which is suggested by the panspermia theory. We already have a video on the panspermia theory, so if you want to know more about it, click on the video here in the cards. Juno's breathtaking images and valuable data have sparked public interest and allowed scientists to create detailed maps of Jupiter and its moons. These maps help us better understand the planet's chaotic cloud systems, intense radiation belts, and the forces that shape its environment. Originally planned as a 20-month mission, Juno has far exceeded its expected lifespan. NASA extended its mission multiple times, allowing it to continue providing valuable data. The spacecraft has adjusted its orbit to study Jupiter's outer regions and even conducted close flybys of some of its moons. offering a broader perspective on the Jovian system. The mission's future includes plans to study Io's intense volcanic activity in greater detail, as well as continued observations of Jupiter's dynamic atmosphere and magnetic field. The spacecraft's mission will end in September 2025 with a dramatic conclusion. To prevent any chance of contaminating Jupiter's moons with Earth microbes, NASA plans to guide Juno into Jupiter's atmosphere where it will burn up. This decision reflects a commitment to protecting potential habitats for life, especially on moons like Europa. While the spacecraft's journey will end, the data it has collected will continue to fuel discoveries for years to come. Juno has revolutionized our understanding of Jupiter and the broader solar system. Its discoveries have challenged existing theories about gas giants, provided new insights into planetary formation, and inspired countless people to take an interest in astronomy. Moreover, the success of this mission demonstrates the importance of space exploration and international collaboration in advancing scientific knowledge. The mission has also highlighted the value of public engagement, with JunoCam images fostering a sense of wonder and curiosity among people of all ages. It has revealed the beauty and complexity of Jupiter, its moons, and their interconnected system. By studying the gas giant's storms, magnetic fields, and volcanic moons, Jupiter has helped scientists answer big questions about our solar system while raising new ones. As Juno completes its mission, it leaves behind a wealth of knowledge that will guide future explorations and remind us of the wonders waiting to be discovered in the universe. The mission is a testament to human ingenuity and our desire to explore the unknown. As the spacecraft continues to orbit Jupiter, it brings us closer to answering some of the most profound questions about our solar system. Whether through its stunning images, groundbreaking discoveries, or the mysteries it has yet to uncover, Juno reminds us of the infinite possibilities that await us in the cosmos. Stay tuned for more updates from this incredible mission, and don't forget to look up at the night sky. It's a reminder of how vast and wonderful our universe truly is.